Hey guys, thank you for having me. I'm excited to tell you more about Ritual and some of our learnings with AI crypto the last 1 or 2 years. This is maybe one of the biggest events I've seen for AI crypto, so thank you to the organizers for putting it together. Just with a quick show of hands, how many of you in here are crypto people? Would you define yourself as? Okay, hands down. And how many are AI people? Pretty good. Cool. And then all of you are in this set. So excited to talk more. So I am the founder of a company called Ritual. And the goal of Ritual is to make it very easy to integrate AI models into smart contracts. And I'll talk a little bit more about the kind of goals of the company, but I really wanted to create this presentation in a way that shows maybe a little bit more of the kind of philosophical underpinnings of this space, and then go into kind of a technical, not deep dive, but somewhat surface level presentation about how we're actually going about this, this task. So the motivation here is, as everyone here in the room knows, AI has become a massive thing in the world. It's finally crossed the chasm into real usage. Now we have hundreds of millions of users. The AI, you could think of it as the intelligence quotient, has gotten to a pretty significant degree. And so what this leads us to is, I think there's a lot of problems with the existing stack today. Infrastructure is highly centralized. The storage, the governance, the ownership, the compute is all really run by a couple of corporations. It's also highly permissioned. A couple of geographies, you can access it through a few APIs, and it's becoming increasingly regulated. There are a bunch of governments and corporations that are trying to attempt regulatory capture with this technology. So what is the future impact of this? The future impact is AI is going to be integrated into every single product in the world as we know it over the next 10 years. And this leads us to an open problem, which is, these things are creating highly engaging ways to interact with products. And what we need to do with this is really protect people in the world and protect users. A good analogy, I think, that we've seen in the past with this is around the export of cryptography in the 90s. At one point, cryptography was treated as a munition, and you literally could not print cryptography onto a CD and take it across a border. That would have been illegal. And I think there's a very similar thing happening here, which is sort of an argument around freedom of speech and how these models are regulated. And so ultimately, open and transparent governance of AI models is key. Sorry, these are a little wordy, but this is where I believe AI crypto has a really interesting place in the world. Crypto has given us these really amazing primitives. You get privacy, you get computational integrity, you can do coordination and incentives. And so creating this open infrastructure allows us to catalyze new usage and provide credible neutrality for this AI crypto layer. It takes this kind of current state of centralization and makes it open at the distribution level, at the cryptography level, and more. And this does feel like an important thing to decentralize. We've decentralized money and IP and art and a whole bunch of other stuff. And this is, I think, an important one as well. So what does Ritual actually do? What we're trying to do is we're trying to make it very easy for a developer to integrate AI into their applications. So we're really interested and focused on the distributional problem. We're taking this from the lens of Web2 AI is already massive, and we think the best way to bring about a world of decentralized AI is to get all of the Web3 AI-enabled products to have a ton of usage. So what we're doing is we're taking kind of a combination of these two worlds to build these new AI-enabled dApps and really offer this kind of all in a kind of blockchain incentive layer that allows you to build a lot of programmability that you can't otherwise today in AI applications. So what we've built today is kind of a set of two phases. The first phase is a product called Infernet. An Infernet is a decentralized Oracle network that's built for AI that allows you to plug into any blockchain and use AI compute on it. This is a pretty big deal because you can't really do AI compute in an easy way on blockchains today. It's too inefficient. No one's really built any of the tooling, and so we built it. And FriendRug, which is an application, a demo application we built, I'll discuss in a few slides, but we built this all using Infernet. And you actually can also set up a node today and start playing with it and using it. So you can actually host a node or a set of nodes yourselves and plug those into your smart contracts. The second phase of what we're building is a chain. There's a sovereign chain, the custom VM and coprocessor that is purpose-built for AI native operations. An analogy I like to use is, in the IPFS Filecoin system, the IPFS, the model or the storage objects really are kind of the atomic unit of that system. And for us, the atomic unit are models. AI models sit at the center of the chain, and it's really the first-class citizen in this network. And then you can do all these different operations on these models. Inference, fine-tuning, model quantization, distillation, things like that. I won't go into this too much, but this is kind of a diagram of how we're thinking about this. And the important takeaway here is we care a lot about modularity, basically. We want to be able to plug into other networks and allow for things not only to happen on our network, but on other networks. So ultimately, I think that's the best way to kind of offer a lot of value into the ecosystem, to not make it tied to just one specific place, which would be our chain. Okay, so what is on Ritual? Ritual today already supports injecting AI models into applications with the optionality of proofs and things like that. And so what is in Ritual Chain? It's a set of stateful precompiles that makes the AI operations I just mentioned very easily accessible to developers, inference, fine-tuning, and things like that. Secondly is a proof marketplace. So I know we had some talks today about zkML, probably some things about OPML. We want to be able to offer any type of proof system to any type of user. The user of a DeFi application is going to require a different type of integrity than the user of, say, a social app. And I think we want to be pragmatic in thinking about what type of security we need for what types of applications. I mean, maybe it's even a TE or something like that, something weak security but good enough for most people. This is all built on a modular stack, and you can really plug into decentralized model storage, other chains, and things like that. Okay, so what are the technological pillars that we're going after with this product? One is censorship resistance and decentralization. We're trying to attack the problem of what if Hugging Face goes down? What if you can't access a model in 40 or 50 countries? Attacking the problem of having all the major open source models heavily red-teamed and censored. Privacy and integrity. Today, you basically have zero privacy or integrity whenever you use any AI product on any Web2 platform. So we want to, from the start, bake in these primitives that allow you to have, full end-to-end transparency of what's actually happening when you're doing this compute. Then finally, and maybe most exciting, with blockchains, is now allowing the ML stack to have incentives inside of it. Everything from the data labeling level, to the compute, to the model storage, all of these things can be built with programmable incentives, which I think will be a very powerful tool these next 3 years to bring on a ton of users and a ton of effectively contributors to these different parts of the stack. And we're not focused on all of these, but this is really high level to think, for people in the room that are starting AI crypto companies, ways that you can think about, really supercharging what you're building. Okay, so people ask a lot about what the use cases of AI crypto are. I think there's a ton of really exciting ones, and I'll highlight a couple. One is, effectively programmatic DeFi. Human governance today is highly manual. We can't take the DAOs that we have today and scale them up with more humans. I just don't think it'll be possible. So what DeFi allows you to do for actions that are verifiable is you can stick an ML controller in the loop and use that as an ongoing feedback mechanism for improving that DeFi system in real time. That's a lot better than going and having to go off chain and write some simulations and convince a couple of big holders to vote yes or no on the decision. And I think this is a really interesting lens to think about the world, which is, can we have these controllers that are actively changing and improving blockchains, which today are very human-driven. Next is kind of the generative use case with gaming and entertainment, being able to generate characters, speech, things that are custom to you. So if you have a certain set of preferences, maybe you want a game to be built in a manner that you'd like it. Content and media, pretty self-explanatory, but now being able to create things like new art, movies, videos, and then have all of the content and kind of structure licensed via an NFT of some sort. Then finally is governance. Things like being able to generate proposals and maybe even things like an AI judge in the future are very exciting areas of exploration that people should be thinking about more. Okay. Crypto-enabled AI. What does this mean? So all of these different cryptographic and game theoretic primitives allow for this sort of plug-and-play ease of use into model privacy, model origination, governance, computational integrity, things like that. There's a lot happening around data provenance, what's actually going into the models as you're training them and then doing inference on them, fine-tuning them. Incentives, as I've mentioned before, and governance. Okay. So this is a case study of something that we built to show off the power of LLMs on-chain. So everyone, or many people in the room probably remember FriendTech. It's still around, not as much usage anymore. But what we built was, normally in a FriendTech room, you buy some keys to enter the room, and then you can chat back and forth with that person that you bought the keys with. What we did is, instead of a human, we put an LLM behind it. And we trained and created this game that allows you to basically try to convince the bot to buy and sell your shares. We trained it on hundreds of examples to make it pretty difficult to do. And there's a bunch of different pieces here that are kind of exciting to talk about. One being, there's kind of an on-chain classifier piece, which is using Ezekiel proofs, so it's fully transparent. Several different LLMs are kind of being fed in to bring this kind of non-determinism into the system. And it's all fully open source. So you can check it out. You can build more things like it. We'd love to see more things built that are like this. And no one has cracked it yet. So it's kind of a fun. There's actually 10 ETH in the prize pool. So if you can figure it out, there's some money waiting for you. Okay. There are a ton of really interesting open research directions that we would love to collaborate with people on. I've mentioned a bunch of them in the talk already. Everything from proofs of compute to privacy, transparent and open source foundation models, compute routing, data retrieval and provenance, autonomous agents. So please reach out if you're building anything in this area or are interested in building anything in this area. Okay, we're right at the end. How can I participate? We have a way to, for anyone to participate, which is running an Infernet node. You can actually go to the Ritual website, download it, set it up. It should be pretty simple. If it's not, tell me, and we'll make it a little easier. Building on our network. We just launched a Discord last week, and we have a ton of community folks starting to build interesting tooling in this ecosystem. And so go there for project ideas. Over the next 4 or 5 weeks, we'll be announcing some of the early dApps that are building on Ritual. And so this will really be some of the first crypto AI apps that you can use today, which is kind of exciting and something that we are proud of and excited to push the space forward with. And, of course, more things coming out as we further open source. And that is it. These are the best ways to contact me, the team, and to learn more about what we're building. And do we have time for questions? Yeah? And then happy to take any questions.
By putting the AI on the validator, would you be up for it?
I would like to learn more about what your building is so I can learn how it works to answer your question better. I'll give you kind of a rough way that I've seen some security stuff happening in the AI crypto space. There has been a lot of interest in using reinforcement learning for doing things like hack detection, things like that. I think it'd be really cool to have like Trail of Bits or someone like that set up a DAO. Maybe they can keep the weights private and use that to go and find vulnerabilities on chain and go and basically collect them and kind of be like a white hat DAO sort of thing. I also think it'd be cool to see people build more code gen tools around the crypto native languages. Solidity, some of these ZK DSLs, things like that would be very, very cool to see. I haven't seen too much there yet, but if anyone's building it, I would love to talk. But yes, we'll talk after. I know I didn't answer your question, but I need to learn more about your system before I can answer more accurately. Yeah. Yep.
What kind of code gen tools? I have a question, but I would just wanted to follow up on it. What kind of code gen tools?
So if you look at all of the large sort of code gen things out there today, the Solidity support is pretty bad. It's not a lot of examples. And so there's a lot of really talented auditors and Solidity people in the space where we should make the code gen tools really, really smart, because then it can inform some of these use cases, like having an on-chain white hat DAO or something like that. It's a kind of a long-term pie-in-the-sky idea, but I think it would be really cool.
My question is, so on your blockchain, so you said phase 2 is that you're going to be building your own blockchain. You've already started. If I run a model, what's the computational model? If I want to run a model, like, as on-chain, on that chain,
right.
Am I publishing the architecture? Am I publishing the weights? Are those like common knowledge across all the validators? Like, what does that look like? Or what will that
Sure.
look like?
So today we are focused on, so Infonet supports both open source and closed source models. Obviously with closed source, you're not really getting any privacy or computational integrity or censorship resistance. It's on the Oracle network. I think the kind of 1 year out future is we're focused on open weights, so kind of transparent foundation models. I do think it'd be cool if the technology improves to have things like weights that are kind of privately held, but you can still do inference on them. That'd be pretty cool and still transparent. I haven't really seen too much there yet. The state of the art in MPC and stuff is really slow, like tokens per minute kind of thing. So I think we need some speed ups there, or maybe in the hardware space before we can get to it. But yes, we are focused kind of all the weights will be stored in kind of an open way and between all the different validators.
I have a question about the nodes. Now, in a blockchain network, the nodes are all equivalent because the protocol irons out any differences in CPU computational speed, so it doesn't matter. But in AI, it's different. Inference really matters, and the more GPUs you have, the better off you are. And you mentioned that you don't need a GPU to run a node. So I'm just curious what's running on the node.
Yeah, so maybe I should give a more detailed system requirements. So you don't need a GPU to run a node in the sense that there's a class of models that don't require GPUs, especially if you're not ZK proving them, or you're doing outsourced proving or something like that. And so I'm thinking older class of models, classifiers and decision trees, things like that. And small models, doing inference on them on a CPU is actually efficient in some cases for kind of smaller use cases. But you're right that if we're serving bigger models and you're competing for these jobs with other people, you're definitely going to want really, really good GPUs and to kind of bring into the system. I don't think we're there yet today in the sense that the competition is not that great, but I think it will get there at some point. Got it? Okay, thank you guys.